Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Rizqy Fridion. My student identification number is 21130222036 from Faculty Teacher Training and Education. With the study program is Physics Education. I'm a group 10 from Class B, Lampung University. Now, I will explain about pressure in fluid. At the first is fluid pressure. The fluid will exert pressure on every surface area that isn't in contact with it. Pressure is defined as the force acting on a surface divided by the surface area. This explanation can be written in the following equation. The formula is pressure is force divided by surface area of compression plane, where is the pressure in Newton per meter square and force in Newton surface area of compression plane in meter square, where the pressure will be greater when the surface area is getting smaller. Surface area is getting smaller. Back to fluid pressure. Fluid have the property of compression in all direction, meaning that for the example, if you put an object into a type of fluid, it will experience pressure in all direction. The amount of pressure exert, exerted by the fluid depend on the depth of the object. In direct proportion, the deeper the object is, the greater the pressure. The pressure caused by this fluid is often referred to as hydrostatic pressure. And the next is hydrostatic pressure. Hydrostatic pressure is the pressure exerted on a liquid that is at the rest or in equilibrium due to the influence of gravity. The amount of hydrostatic pressure obtained by a substance is determined by the magnitude of gravity due to the position of depth and the density of the liquid. A small volume of fluid at a certain depth in a vessel with the exert upward pressure to balance the weight of the fluid above it. For a very small volume, the stress is the same in all directions, and the weight of the fluid above the very small volume is equivalent to the pressure, which is defined as follows. Formula is hydrostatic pressure is density of the fluid or ρ times acceleration due to the gravity times height of the fluid column. Where is the hydrostatic pressure in Pascal? Density of the water of ρ is kilogram per cubic meter. Acceleration due to the gravity in meter per second square. Height of the fluid column in meter. And the next is the example of problem about hydrostatic pressure. And the problem is if the density of water is 1000 kilogram per cubic meter and the acceleration due to the gravity is 10 newton per kilogram, the hydrostatic pressure received by the fish is, that's the now is height is 140 centimeter minus 60 centimeter is 80 centimeter is zero point 0.8 meter. Then and then is density of water or Rho is 1000 kilogram per cubic meter and the acceleration due to the gravity is 10 newton per kilogram. With the formula of hydrostatic pressure is density of water or Rho is time acceleration gravity times height is 1000 kilogram per cubic meter times 1 newton per kilogram times zero point 0.8 meter. Is the answer is 8000 newton per meter square. And the next is atmospheric pressure and absolute pressure. Atmospheric pressure. Pressure at a certain depth is also influenced by atmospheric pressure. Pressing the upper surface of the liquid layer. So it can be used to determine the total pressure at a certain depth in a liquid. And then is absolute pressure. Absolute pressure is the total pressure experienced by objects that are in water and is expressed by formula is absolute pressure, it's atmospheric pressure plus hydrostatic pressure. Is the atmospheric pressure plus rho times acceleration to the gravity times height. So, if we do experiment and get data about pressure, it is necessary to add atmospheric pressure. Okay, I think it's all from me. Thanks for your attention. Wassalamualaikum warahmatullahi wabarakatuh.